Welcome to the Cycle Computing video series. In this video, we'll show you how to use CycleCloud's Cluster-Init feature to perform custom configuration steps on CycleCloud instances. Cluster-Init is a tool for copying data onto instances and running customer-defined scripts. Some common use cases include pre-staging reference data, installing software packages, and verifying the instance is properly provisioned. Each of these use cases will be examined in detail momentarily. Once you have your cluster-init tree set up, you can use it to repeatably deploy consistent configuration to multiple clusters and users. Reusing pieces of your cluster-init allows for quicker onboarding of new users and workflows. Cluster-init has a defined structure consisting of 3 directories: Scratch, Shared, and Executables. The Scratch directory contains data that should be copied to each instance. This may be configuration files, software packages, source code, or other files that you may want to have available on disk. The Scratch directory may contain subdirectories. The Shared directory is similar to the Scratch directory, but it is not copied to every instance. Instead, it is only copied to the node with the filer role and is shared via NFS and Samba to other nodes in the cluster. This makes the Shared directory well suited for larger sets of reference data that you do not want to have each instance pull down individually. Like the Scratch directory, the Shared directory may contain subdirectories. The final directory is the Executables directory. This directory contains either Linux shell or Windows batch scripts that are run in alphanumeric order. In order to make the execution order explicitly visible, we suggest prefixing script names with a number. Executables can reference files in Shared or Scratch, or system files already on the image. In addition, executables can use CycleCloud's Jetpack tool to reference the instance's CycleCloud configuration or to send messages back to CycleCloud. This allows for a single executable to behave differently based on an instance's characteristics. Once you have your cluster-init tree defined locally, you need to put it into your Cloud Locker. This is a cloud storage location that you created as part of your initial CycleCloud setup. Your cluster-init files go into a directory called cluster-init/version name, where the version name can be any string. Some customers use this to create a separate cluster-init tree for Windows and Linux nodes, while others may use it for versioning. You can upload the files with any tool that can write to your cloud storage, like Pogo, or CycleCloud's DataMan data transfer feature. When your instance is being configured, the cluster-init tree is copied from your Locker. First, the directories are synced to the local disk in Mount Cluster-Init on Linux, or C Cluster-Init on Windows. Newly created or modified files will be downloaded during every maintenance converge process. Next, the executables are run in alphanumeric order. Scripts are run as root on Linux and administrator on Windows, so you have full privileges to make the system changes needed for your instances. If a script fails, it will be rerun during the next maintenance converge process. Scripts that complete successfully will not be rerun. New scripts that are put in the locker after the first converge will be run, but modified scripts will not be rerun. By default, a failed cluster-init script will mark the converge process as failed, and the node will not enter the ready state. If you have scripts that can fail but still allow the node to be considered ready, this behavior can be disabled. If you need to troubleshoot an executable, the standard out and standard error streams for each run are saved to the logs directory within the instance's cluster-init directory. Now that we've shown how cluster-init works, we'll go into more detail on the use cases mentioned earlier. The first use case is pre-staging reference data or executables that your jobs will use. This requires putting the necessary files in the Scratch or Shared cluster-init directory. Your job could reference, for example, mount cluster-init scratch myinput.dat. Alternately, you could have a script in the executables directory that copies the files to a different location on disk. Another common use case is the installation or building of software packages. For simple installation of an RPM, DEB, or MSI package, you would put the package in the Scratch or Shared directory and have a short script that calls the appropriate installation command. For software packaged in a zip or tarball, You would again put the source bundle in the Scratch or shared directory and have a short script that extracts it to the desired location. A final variant of software installation is building a package from source. For most software packages, this is a lengthy process that you do not want to repeat across many nodes. However, using a cluster-init script to build on a CycleCloud managed instance is a good way to ensure that your build environment matches the cluster environment. The best way to do this is to stage your source and any dependencies in the Scratch directory, and script your build steps in the executables directory. You can even use Pogo to upload your final package directly to the cluster-init tree used by your computational cluster. The third use case is detecting misprovisioned instances. Cluster-init runs as part of the initial configuration process and completes before the node is marked as ready, so that makes it well suited as a framework for detecting provisioning errors. CycleCloud can often detect issues, but sometimes problems are not obvious from the outside. One example is if a network connection is not getting the full bandwidth available. One customer found a case they could detect with a simple script. If the script detected degraded networking, it caused the instance to terminate, and CycleCloud launched a new one. Without this check, jobs would run at half speed, which might not be noticed for several hours. CycleCloud's cluster-init is designed as a one-time initialization tool, so it is not appropriate for every case. If you need ongoing enforcement of changes, or if you need to make changes to long-running instances, you may want to consider a custom chef cookbook or other solution. In addition, staging large volumes of data can have a significant impact on the speed at which instances are made available to your cluster. When you have a large amount of data to put on every instance, CycleCloud's Jetpack tool can be used to build your own cloud image that has the data baked in already. We will cover custom images in another video. Now you have seen how cluster-init can be used in a variety of scenarios to make CycleCloud instances more repeatable. For more information, see the CycleCloud documentation available at cyclecomputing.com.